Even people who haven't taken physics know Newton's third law. Outside of physics, people normally say for every action, there's an equal and opposite reaction. In physics, of course, we replace the word action with force. And so to us in physics, Newton's third law is for every force, there's an equal and opposite force. The classic, of course, is a push-up. Now we'll start down here with a boy with his chest on the ground. Now when he pushes, he's going to push down, isn't he? Call that the force of the boy. Now, but his body moves up, doesn't it? Interesting. That force going down cannot move him up. What's going on here? Let's find out. Now, I like to diagram these what are called force pairs in this little template here. And as you may recall, we have an action force, which usually gets things moving. Usually there's a force that comes first. In this case, it's going to be the boy pushing down, isn't it? So we can fill this out here. Here's a boy pushing down with 300 newtons. We'll go with the boy is exerted on the ground. The magnitude is 300 newtons, and of course his force is down. Now that cannot move him up. That'll push down on the ground. However, because there's an equal and opposite force, we have a reaction force here, and that is the ground pushing up on the boy. Now, with this little template, all you do is reverse these two, don't you? The boy ground becomes ground boy. Now, it's equal and opposite, correct? See our equal right here? This is also 300 newtons here. Opposite, this was down, this one's up. And there you have it. You have your action force and we're in your reaction force. And now we have a force directed upward, don't we? A force that can move his body up, and of course it does. The last question down here then is which force causes movement of the boy's body? And the answer there is the reaction force, isn't it? It's up. It can move him upward. What do you think? Do you think there are any exceptions? Are there any forces in the universe that don't have a partner? A force all by itself, not in a force pair? Well, of course, the answer is no. And even in this weird example here, the ball's falling here, right? I think it's probably clear to you that the action force is gravity, right? And here's the action force. It's the earth pulling the ball down. That's where gravity comes from. The earth pulling the ball down, and it's blocked out down here. You probably can't see it, but we have our weight formula over here. W equals mg. The mass is 2.5. The weight is 25 newtons. So the magnitude is 25 newtons, and of course this is down. That's gravity, correct? Now, the kind of unusual thing here is the reaction force. We reverse these two, don't we? The ball pulls on the earth. Isn't that kind of strange? The ball pulls upward. Of course, it's still 25 newtons. This force here is down, so this one here is up. That's the opposite. So the ball pulls up on the earth, doesn't it? Of course, the earth doesn't move very much because it's so darn heavy. So the question is, which force causes the movement of the ball? And the answer here is the earth pulling down. It's the action force, isn't it? And that's it for Newton's third law. And here's your video code. Please write it down.